Okay, ladies and gents, this is going to be the required practical, and we're going to look at capacitor combinations. So we have equipment wise power pack, so very fine detailed power pack, okay, that can run on that. We've got a voltmeter. We have on the worksheet, it says a bulb or an LED with a resistor, but we're just going to use a resistor and measure the voltage, and I'll tell you why in a bit. Stop clock, I will use mine. However, if you're not watching this on your phone, I would suggest you use your stop clock while watching it on your laptop. It will probably be more accurate. And then we have a few leads and various sets of capacitors and unknown resistor. Okay, so we'll go through those in a bit, but our basic circuit is a power supply connected to our capacitor, and it's also connected in parallel to our resistor. Okay, so how does the circuit work? Well, just like the ones in the PowerPoint, what you see here in front of you is a capacitor and a resistor, so a discharge. We've basically got the two circuits. So coming in on the left here, you've got your power supply, so this is your charging side of the circuit, and then over here we've got your discharging side as it goes through the resistor from one plate round to the other. Now, we haven't got a switch in the middle to switch between charging and discharging, because actually we've got a slightly sneakier method. So what I've got here is when I turn the power supply up, you'll see the voltage output, the voltage on the resistor going up, and we'll make that a nice round number like 10. There we go, so well within the rating. What I can do is, as soon as I unplug the power supply, there's no circuit on the left. So at the moment I'm supplying electricity to the resistor and the capacitor. Okay, so yes, I'm getting a voltage on the capacitor, but I could be measuring it just as easily across the capacitor. If I take the power supply lead out, then straight away you can see the voltage drops. The charge in the capacitor is dropping. We can tell by measuring the voltage. Q equals CV. So smaller Q, smaller V. Now, one thing worth noting, and I'll instantly charge it back up again. There we go. Connected to the power supply, is that when I let it discharge, it doesn't discharge evenly. Now, you saw that in the video, perhaps with the bulb. It wasn't very clear, but it's much more obvious here. So, going down quite quickly to start with, it's reached 6 volts there, 5 volts, 4 volts, 3 volts, 2 volts. Yeah, so the rate at which it slows down, sorry, the rate at which it goes down, it gets slower and slower. Okay, the rate is smaller. And in theory, it will take forever to actually reach 0. So, in your practical, what you need to do is time how long the capacitor takes to empty, but you won't fully empty because it's not reached 0 yet. Okay, so what I want you to do is, I'm going to use this 10 volts as our starting place each time, but I would like you to decide where you're going to time it to. So start your stopwatch as soon as I remove the lead, and then maybe, for example, time how long it takes to get to 6. There. Or perhaps 4 volts. There. Okay, so you decide which you think is useful. I suggest you play that bit of the video back again to recheck it and think which would be a decent time. It does not matter which. If we had a bulb, which is what it says in the practical, you'd find out how long before the bulb got to a certain dimness. A bit easier to actually see if we take it off a reading. Okay, I swapped the voltmeter to make it a bit easier to read. So take the numbers off the scale. My timer, I'll prop up there, and we'll put that on in a second. What I was going to do, and what's on the sheets, is you should be using these capacitors, but they won't fit into the circuit. So I have changed the value. Okay, so we're going to be using combinations of C2 capacitors, labelled up as C2. we're going to put them in series, in parallel, different combinations, so that you can work out the capacitance. Okay, the capacitance of the combination. So we're going to start off with one on its own, and just to make clear, I'm sure you can see that they are 2,200 microfarads. So all of my C2 capacitors are exactly the same, 2,200 micro. So I'm just going to slot it in and make sure the polarity is the right way around, because otherwise it gets really upset with things. And I'm going to again measure my voltage across my unknown resistor. That's part of your challenge. So I'll just churn that down, make this a fair test. He says, hang on, it's right on the bottom, so let me just turn up a little on there. So we'll make sure it's on 10 volts each time. Okay, so we can get a nice accurate reading for time. And whatever you have decided to be the number that we're going down to, let me just adjust that a little bit more. It's right on the verge of going to 1. There we go. So 10 rather. So we've got 10 volts on our supply, 2,200 microfarads, and unknown resistor. We won't change that. We won't change that. Control variable. Okay, so what we're going to do is simply time how long it takes, and we'll synchronize this. So as I say, I would, if I were you, I would use the capacitors, the timer at home, because it's going to get a little bit squashed for space in a bit. So what I'm going to do is I will take the lead out. Don't worry a second, I know it will start going down. Okay, I've just moved the resistor across to make it easier to see. So there's our capacitor, unknown resistor, that's going to stay the same, that's going to stay the same. Okay, so when I unplug the power supply, you can see how quickly it's going down. Okay, but it will slow down as it's going along. Okay, so have a think what voltage you want to drop to. I'm not going to go down any further than 4, but you decide, or roughly 4, but you decide somewhere, some value is going to drop to. Some will be faster than this, some will be slower than this. In fact, it might drop a bit lower than that. Okay, so let's just run that through. Okay, adjust it, get it on 10 volts, and we are going to unplug. Ready, steady, go. Okay, going to stop it at about 2. Yeah, about there. Okay, so play it through, rewind the video, retake your readings. You can double check very easily. We're going to just now change the circuit ever so slightly. And what I'm going to do is I'm going to make my circuit bigger. And what I'm doing there is I'm actually going to connect in another capacitor. So what I'm going to do, same value, but now there's 2 capacitors, in series. Okay, so you're going to need to work out what the capacitance of that is. So 2 capacitors in series there, and what we'll do is we are still measuring the voltage across the resistor as it discharges. So that is the voltage across the 2 capacitors. Okay, so there's our 2 in series, just going to hide that behind the clock now, and ready for the power supply. 3, 2, 1, go. Okay, so that is definitely much faster. as I say, you might not want to listen to me saying ready, steady, go, because I'm trying to do it all myself at the same time. So you might want to just start your timer when that starts moving, when the numbers start moving on the voltmeter. So move it up again. Okay, so we're going to have now the maximum combination. So we've only got 3 capacitors, and we'll slot the third one in. Again, it's going to be in series for this. Okay, so adjust, we're on 10 volts and we're ready to roll. 3, 2, stop that. 3, 2, 1, go. Okay, so that was really quick to go down. So it must be storing less charge because it's taking less time for that charge to escape. Okay, so have a think about that in terms of the physics. But for the practical, work out the capacitance, find out the times. You've got 3 times for 3 different capacitors, 3 times for 3 different capacitors. And you can plot those on a graph, that time to reach to drop to a certain voltage against capacitance. Okay, and now what we're going to do is I'm just going to set different circuits up. We will go for parallel and we'll go for combinations. Okay, so I'll point out when we get them. Okay, this circuit, from the power supply you've got 2 in parallel followed by 1 in series. Okay, so there's 1 on its own going up from the 0 volts, then there's 2 side by side above it, and then the top voltage. Okay, so again, slight adjustment, tiny bit high on the voltage, there we go, 10 volts, and we will get ready to roll. 3, 2, 1, go. Okay, that's should be long enough. So we go back up to 10. Now then, what I'm going to do now, and I'll move this at the same time so you can see it, is I'm going to take that and link it there. So actually I now have 1 in parallel with 2 others. So 2 in series, and in parallel with that I've got a single one. Okay, so it is a different setup. Again, you can draw it out from the symbols. It's fairly straightforward with this. Adjust it, we're on 10 volts, so I will start it. 3, 2, 1. Okay, we'll stop it there. So what we've got here, if I get that out of the way, I've got a resistor and I have 2 capacitors in parallel. Okay, so those are just side by side. I can actually simplify that even more with my circuit, which might make it a little bit clearer. There we go. So all I have are my 2 capacitors in parallel with my single resistor. So let us get that out of the way and let's get ready to run with those. Okay, so 3, 2, 1. Okay, that's quite slow because that's got twice as much capacitance as one on its own. Okay, so a nice bit of easy math that. As I say, each one is, I'll show you again just in case you need to find it, 2,200 microfarads. Okay, last bit, I'm going to just have to move things around a little just to make it work. I'll slide my resistor across, slot it in, and I'm going to put my third capacitor in the space. I'm going to try and fit it in on top of each other. Always a little tricky. There we go. Let me get that squeezed in. There we go. So just need to make sure they're all clicked in. Great. So I've got 3 capacitors. Move that back there. 3 capacitors in parallel. They're going to be quite slow. Okay, so this should be our slowest. Our slowest reading. Let's go back to those. Okay, so ready for this? Our last reading with our known capacitors. 3, 2, 1, go. Okay, it's really dropping quite slowly now. Hopefully you chose a slightly higher voltage so then you could measure it without waiting too long. But I'll let it run down to about 2.5-ish volts. Okay, that should be enough. So what I'm going to do now is set up the last practical. The extension activity with this is quite hard. You'll need to think about it a bit, but trying to find out what the unknown resistor is. Okay, now what I'm going to do now is the main task. So plot your different capacitors against your different times. You should get a pattern. Okay, a nice clear pattern. Sorry, you'll definitely get a pattern. And then what you're going to need to do is I'm going to put this capacitor in. Okay, so let me just move those out, clean the space, move that one out. So we're just going to have a single capacitor, or rather, to be precise, it's actually a combination, so there's couple of capacitors put together, but we're going to treat it as a single capacitor, capacitor 3. What we're going to do with this one is, by using the time, finding the time for exactly the same readings, you can get from your graph the value for C3. So let me just reset that. We'll have a little tweak. Now it's on 10 already, and what we'll do is, if you're ready, we'll drop it. 3, 2, 1, go. So it's quite quick. It's definitely not as long as those last 2 results. So you've got a rough idea what the value is. Okay, so that's the kind of fun you can have at home when you bring home all the circuits.